with an arrow on top, and the arrow is determining the direction of a vector. So the length of this line, the length from here up to here, determine the magnitude of that vector. We shall see how to determine the magnitude of a vector. Then the arrow is giving the direction. Is giving the direction. That is the first aspect. Then the second one is the B part, the symbol we use, symbolic representation of vectors. We said analytically, a vector is represented using a bold letter or a letter with an arrow or with a bar above it. If you are writing with an arrow on top or with a bar above it, then you write A, then you put the arrow, which means this vector is, we know that when we are determining direction, we move from left to right. So that's why the arrow must be pointing. When you reverse that direction, that one becomes a negative. Okay? So that's when we have A with a bar on top or with the R on top. That's one way we can symbolically represent a vector. Then another one we have A with that symbol down. That symbol is called nabla. Okay? So you read it as A nabla. Okay? This one, when you're reading, you read as vector A. A nabla, which still represent nabla is a symbol for is also a language we use in vectors. Okay? Are you together? Are we together, members? Yes. This symbol is called?
Yes.
This one is called? This one. I said this one is called what? What is this symbol called? This one. It's called what?
Nabla.
Nabla. Nabla. Then this one is it?
Vector A.
Vector A. Okay?
Vector A.
Yes. So if you are using small letters, these are the symbol we use. Okay? And remember I said we use bold letter. Now someone may ask, how do we use a bold letter now when we are writing? You cannot exactly use a bold letter, but what is the most important thing here is the arrows on top. Are you together? You don't need to bold it, but the most important thing you have to not to forget when you're presenting vector is to put the arrow on, top, or to put this symbol nabla, the nabla symbol. Okay? Are you together?
Yes.
So which means I can write A like that, which means this vector is moving from, when you see this one, AO, which means we are moving from A to O. Right, together? We are moving from A to O, or to point O. Put that thing down. We have this point O, then point A. And that point is represented by a vector A. So which means OA is represented by vector what? Is presented by vector A. O and A, these are points. These are points. Along the line OA. Right, together?
Yes.
And another thing to note, the line must be straight. Remember we said vectors are has both magnitude and direction. So you must be positioned to specify the direction, and the length determines the magnitude of that vector. Are you together? Yes. Then another point to note is C, what we call the sign convention. Correct that that's not seeing, should be sign convention. Sign part C is what we call the sign. The sign what? The sign convention. Like I said once now, the arrow is giving the direction, which means when you reverse the direction of the arrow, what does it mean? Which mean that vector become a negative. So which means when I write AO, okay? In this case, is what? Is it a positive? Are you together? But if I change the direction and I say OA, I put O what? OA. This one becomes a negative. So which means in a nutshell, we can just write AO is equals to negative of I think that. Are you together, members?
Yes.
Yes. So we are saying the vector OA runs from point O to A. Therefore, it is given a positive sign. Which is that? Which is that? You can, I believe you are able to see from the notes. But the vector AO runs in the opposite direction to OA. So which means it becomes a what? A negative. It becomes a negative. Is there any question so far? Is there any question so far on how to represent vector? Graphically,
No.
symbolically, and the direction. Is everything clear?
Yes.
All right.
Yes.
All right. Now I'm moving to the next page. Vector classification. How do we classify vectors? Write down vectors. Vector classification. How do we group them? Okay. Vector classification. We have three ways in which we can classify vectors. One is a column
Vector.
a column vector. Then the second one is what we call displacement.
Excuse me, teacher.
Yes, please.
That's the new one or the old one?
Yes. Someone is asking, please. Okay, let's continue. Then the third one we have position vectors. Those are the three ways we use to classifying vectors. Are we together, members?
Yes.
Yes. Now let's look at the first one. Let's start with the A. A, we have column vectors. Column vectors. This one comes from coordinates. I believe we have already looked at coordinates. Coordinates, or what we call Cartesian plane. Do you remember that? Cartesian plane. When I talk of Cartesian plane, I'm meaning X and Y. X and Y what? Axis. Are you together?
Axis.
Yes. So which means we want to, from the coordinates, after writing a coordinate, we know coordinates are ordered pair. Coordinates are ordered what? Are ordered pair number. Which is, we start, how do we write coordinates? We write a bracket, open bracket, X, Y. So X come first. X come what? X come first when we are writing a coordinate in that ordered pair, X, Y. So we can change this coordinate into what we call a column vector. I remember when we are reading a Cartesian plane, if this is our Cartesian plane, this is our Y axis, this is our X axis, okay? And this is our origin. All movement start from where? Members? All measurements start from where? From the origin. From the origin. Good. So which means now, if I have a vector P, which is presented, let me say there's a point there. I think what I'm writing there, from the origin, then there's a point. There's point P, which is X, Y. We know that we know that coordinates. Someone asked, what's the use of coordinate? Coordinates help us to determine positions on a given plane. Are you together? Coordinates help us to determine position. So now we have the first position, now we have position P. But to get to position P, I have first to move X, and then I have to move in the Y direction also. So in this case, it means to get to position P, I have to move what? Y distance, which is that. So this is our X, not so? Then I have to also to move also what? Y. You start, all movement must start from the origin, but you start moving from in the X direction, then you move to the Y direction. Right together. So this is it. coordinate form. This one is in coordinate form. But now how can I change these coordinates into a column vector? Into a column. So we can say P, which is XY, okay? Which is XY, is represented as X, Y. So this is now what we call, are you seeing this one? This is what we call a column vector. Are you together, members?
Yes.
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 Good. Now, example. Let's look at example. Write, the question is write down the following coordinates. Write down the following coordinates as a column vector. As a column vector. For example, if I have 2 and 3, what is that one in column vector? How are we going to write it? Our X is what? What is our X?
2.
Then our Y is it?
3.
So we said when type recall. Recall. I said if you have P, which is XY, in column form or in vector form is going to be X, Y. Not so. So this implies that now when I have 2 and 3 in column vector is going to be the same as 2 and then what? 3. Are we together?
Yes.
Very good. Write for me this one, 0, 0. Write for me that one in column vector form. C, -3, 10. Write for me in column vector form. D, you write for me, -5, -2. Column vector form. Are you through with that?
Yes.
I believe you have something like this. Solution. For B, you have what? 0, 0. Like that, not so?
Yes.
Then for C, you have -3, 10, like that.
Yes.
Then for D, you have something like -5, -2. Like that. So we all know how to change a coordinate into a column vector form. Is there any problem there before we move?
No.
There's no question. We know how to convert, right?
Yes.
Very good.
Yes.
Very good. Let's move to the next concept now. I talk of column vector. The second one was displacement vector, right? Let's go to displacement vector now. Let's go to displacement vector. So we are saying in displacement vector, these vectors represent motion. Remember we said one of the example of a vector quantity is what? A displacement also. What's the difference between displacement and distance? What's the difference between displacement and distance? Yes? What's the difference between displacement and distance? From physics perspective, what's the difference between displacement and distance? Who can give us that? Yes?
Distance is the length between two marked. Distance is the length between two marked points, while displacement is distance moved by a body in a specified direction.
Okay, very good. Very good. That is correct. So if that is true, take for example, let me just use, if I have these 2 points, I have point A, I have point B, then I have point what? Point C, right? Are you seeing that?
Yes.
Now, if the distance from A to B, let me say is 5 meters, then from B to C is 3 meters. What's the total distance there? What's the distance? Distance is what? What will be the distance? The distance we just add, not so. Distance
Yes.
we just add. So it is going to be 5 plus 3, which will give us 8 meters.
8 meters.
But displacement, what will be the displacement? Will the displacement be also be 8?
No.
No, it will not be 8, okay? Why? Let's see how it will come about. Because now if you are moving from point A to point B, that is 5 meters, not so. Then from B to C, that one also what? Which means distance AC. Distance AC is what? 8 what? 8 meters, not so.
Yes.
Good. What is the displacement? What will be the displacement now? What will be the displacement?
It's 2. It's 2.
What will be the displacement?
2 meters.
Displacement will be 2 meters, not so.
5 meters.
Minus.
Yes.
5 minus
3
what?
meters.
Which will give us 2?
3.
Which will give us 2.
2 meters.
So the displacement is 2 meters, but the distance is 8?
8 meters.
Very good. So you can see the difference now. Now let's come back. That was physics. Let's come back now to this. Now, if you have a Cartesian plane, I'm drawing for you a Cartesian plane. This is our x-axis, then y-axis. We have something like that. Are you seeing that on the screen?
Yes.
Yes. Now we are saying consider points. Consider points A. A is what? What is point A? Point A is
1, 2.
1, 2.
Is it 1 and
2.
1 and 2? What about B? Is 8 and
8, 6.
8 and 6. Now, if you are to plot those points on our Cartesian plane, this is my 1. Let me assume this is my 1. Then this is where my 2 is. I'm just assuming, okay? So which means that's our point A. Our point A is there, right? Then, if I take this one to be 8, and then this one to be 6, which means my point B will be somewhere here. So this is my B. So this is what we have on the. I think that.
Yes.
Now, if you are to see this, we shall have something like this, which means for you to move from point A to B, remember all the movement. How did I get to 1? How did I get to 2? All the movement started from the origin, right?
Yeah.
Are we together, members? All the movement started from what? From the origin. So now, what is the distance from here? I think from here up to here is what? Is 8, right?
Yes.
Then from here up to this point is what? Is 1. So what is the displacement there? What will be the displacement? The displacement will be? Displacement?
1.
7.
This displacement will be?
1.
Will be 8 minus?
8 minus 1. 1.
Okay, displacement will be 8 minus 1. Not so?
1.
That is in the x what? In the x direction or in the x-axis. Are you together?
Yes.
So it will be 7 units. Are you seeing that?
Yes.
What about in the y
Yes.
direction? What about in the y direction? In the y-axis, what will be the displacement? Remember, from here, from this point up to point B, what is that distance? Is 6, not so?
6.
Then from here
Yes.
up to here is
Yes.
what? Is it 2? What will be the displacement? The displacement will be 6
6 minus 2.
minus 2, which will give us 4
units.
4 units. So now it means our displacement vector AB, I think I will write it. This is what we call displacement vector, okay? Right together? Is equals to, in column form, in x-axis, what did we get? We got what? 7, right? So which means it becomes 7.
Yes.
Then in the y-axis, we got 4.
4.
That one is it analytically. That's when we analyze from the graph. That's when we analyze from the graph. From the graph. This is what we get. Are you together?
Yes.
Now, using formula, displacement vector, you're just using formula. I'm now giving for formula, okay? Displacement vector,
Yes.
displacement vector AB, displacement vector AB will be just the same as OB minus OA.
Hey.
Are you together? Are you together?
Yes.
So can we prove whether our answer is correct? We want to prove this answer. So which means AB is equals to, what is our OB? O is standing for position vector. Are you together?
Origin.
Yeah.
Origin.
So what is OB? What is OB? When we write it in column form, it becomes 8, 6, right?
8, 6.
Minus,
Yes.
what is it? What is OA? 1.
1,
1, 2.
So when you are subtracting here, we subtract corresponding elements, x minus x, y minus y, right together. So when you subtract that, what do we get? When we subtract that, what do we get? So it implies now our AB will be equals to,
7, 4.
will be 8 minus 1, then 6 minus 2, which will give us 7 and
4.
7 and 4. Have you seen how we get displacement? Are we together on that?
Yes.
Yes.
Good. Another example on that. Another example on that. Consider two vectors. Consider two vectors, A and B. A and B. Assuming that vector A is equals to, I have 4 and 5, and B I have -2 and -3. Can you get for me the displacement vector AB? Determine vector AB. Can you determine vector AB? Let's work it out. So our AB is already a displacement vector. That one is a displacement vector, okay? So AB will be equals to, let's just use formula now. Let's use formula. AB will be equals to, OB minus
A.
OA. So what is OB? OB is equals to, when you write now, in this case now you have to write it in column form. Okay? So it's -2,
Yes.
-3. And OA is equals to 4 and
5.
5. So now can we substitute? So it implies that our AB will be equals to OB, which is -2, -3, minus 4 and 5. Can we subtract that? Have -2 minus 4, right?
Yes.
Then -3 minus 5. What do we get?
5.
We get -2.
-6.
Then negative.
Negative 8.
-8.